Hello, this is the 11th video in the Test First Development series, and I thought it'd be a good time to pause for just a moment and reflect. In those first 10 videos, we've covered a lot of ground and looked at lots of different aspects for how and why to do test first development and write unit tests using NUnit and C#. So the question arises, are my tests really working? Do they do what I want them to do? And if you remember, the purpose of writing all these tests is to make sure that our code is correct, that it's bug-free, that it performs well, that it's doing its job. So how do I know if my tests are any good? Maybe I've written a bunch of tests and there's still bugs in my code. So in this video, in the next few, I'm going to talk a little bit about techniques you can use for really making sure not just that you're writing tests, but that you're writing good tests and that your test library really does what you want it to do. And we're going to start with the concept of code coverage. So to explain the concept of code coverage, I'm going to use a silly metaphor. Imagine you are the conductor of an orchestra and you're getting ready for a performance. You're going to want to make sure that the orchestra has practiced all of the pieces that you're going to perform. If you're planning to perform 5 pieces and there's one of them that you all have not practiced, that's going to be a problem. The 4 are going to sound really good, but when you come to the one you haven't tried at all, well, it's not going to go so well. So code coverage analysis is making sure that our tests exercise all of the lines of code in our project and that there aren't any unpracticed pieces of music. So let me show you one way to kind of visualize that. Here we are in our place order method, and I'm just going to set a random breakpoint here, let's say on line 62. And now I'm going to go to our place order unit test, right click, and I'm going to run it through the debugger. So in theory, that breakpoint should hit, and it does. So we know that if nothing else, our tests are making sure that line 62 executes correctly. And if you extend the kind of thought process, well, if we were to set a breakpoint on every single line in our code, our tests, if they're giving us 100% code coverage, should hit every line. So I happen to know that there's a line in this project now, a line of code that is not being tested. It's right here. We have this rule that you can't cancel an order that's already completed or that's already been canceled. And to prove that this isn't being tested, I'm going to set the breakpoint. I'm going to right click and I'm going to debug through the entire test library. Now, a lot of exceptions are going to hit because we're running in the debugger, and that's expected because some of our tests are forcing these exceptions. So I'm just going to hit F5 and step through all of these. There they all are. And all of our tests, they did pass. That's good. But none of them caused this line to execute. So we have a little hole in our code coverage. So let's plug the gap. Let's practice that piece of music. So I think we'll go back to our coffee shop tests and let's go to our error conditions. And the one we want to test here is attempt to cancel a canceled order. Let's do that one. So to test that, it's not too hard. I'm going to copy this code. So we're going to make an order. And then let's go ahead and cancel it. Where is that? This will cancel it. And now let's try to cancel it again. And all I have to do is put that in. So this is attempting to cancel an order that's already been canceled. So now let's go ahead and run this last test through the debugger. And let's see what happens. Here's a bunch of those exceptions. That's good. And our breakpoint hits. So it's hitting here right before we throw the exception. And then away we go. So we found a place where we didn't have 100% code coverage and we tested it. Now, if you're thinking about this, you might say, well, Matthew, you're testing the code coverage, but you don't really have every logical case. To do that, we would also have to write a test for attempting to cancel a pending order. And that's quite right. So let's go ahead and do that. I mean, attempting to cancel a completed order. So to do that, we would have to write code like this. Cancel a completed order. And we can just do like that. And now we do need to pause for a moment here. So how do we do that? Let's just grab this sleep right there. And if we sleep for 5 seconds and then attempt to cancel, this should also be a problem. I think I cleared my breakpoint. Let's go ahead and put it back. And now let's debug one more time. And let's see, we should hit this breakpoint twice. F5, 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 F5. There's the first time, and there's the second time. So this reveals kind of an interesting thing, which is that code coverage is a very important, oh, I'm so sorry. There were 3 of them, and we had to wait 5 seconds, but I think you saw that, right? We hit that breakpoint now 3 times because we had a few different tests. So this raises the question about, is code coverage sufficient? In other words, if you have 100% code coverage, do you really have full logical code coverage? And the answer is sometimes no. Sometimes there are Boolean cases, depending on how your code is written, that you need to just think about. And then there's another question, which is, well, do you really need 100% code coverage? And I would say that 100% is hard to get to. It's a good goal. You should shoot for it. But it is important to focus on kind of the most complicated and mission critical parts of your code. Having said that, if you took the time to write the code, it's probably worth taking the time to figure out how to test it. So there you go, code coverage. It's a good mental framework for understanding whether or not your tests are doing their job.